Okay, in this video, what we're going to accomplish is uh, to calculate the formula of a hydrate when the by a method which is common in high school chemistry laboratories and college chemistry laboratories. And this is the type of an experiment where you take an unknown ionic compound which is in the form of a hydrate. One such formula is shown here, all right, relative to the problem that we're going to solve in this case. And this would be a copper chloride hydrate where the ionic compound is going to be in a complex with a certain number of water molecules. The dot in this case indicates that the formula will include copper 2 chloride, and then the dot means and a certain number of water molecules. So the dot actually in this case means plus. And what we're going to determine in this problem is the actual number of water molecules. So we're going to find X is what we're going to do. So let's read the problem. It says that we're going to take 3.41 grams of an unknown hydrate. Unknown meaning that we don't know how many water molecules are attached to the copper chloride. We know what type of salt we're dealing with. We just don't know the number of water molecules. So we're going to take 3.41 grams of that hydrate and we're going to heat it, driving off all of the water. And after the water is driven off, then we're going to remass the material, and the new mass is 2.69 grams. So this is the mass of copper chloride remaining after the hydrate has been heated. Now, in a practical sense, the way an experiment works like this is you've got a little glass dish that's called a crucible. So this is called a crucible. And the crucible is heated using a flame. This is my rendition of a flame. All right, and inside the dish is the hydrate. So we heat this thing, and when you heat it, what ends up happening is the H2O molecules are driven off as a gas. And in fact, when you do this in the lab, if you have good observational skills, you're actually going to see the material. It'll appear to melt in a sense. You'll see the formation of the liquid, and then it'll begin to bubble, and eventually the mass of material here will be reduced essentially to a very white sort of brickish salt. The water will be completely gone, and then what you'll do is you'll just let the whole thing cool down and remass the crucible and determine the mass of the leftover salt. Alright, so the way we figure out the number of water molecules is the following. So we know that we've got to start with 3.41 grams of the total hydrate. So I'll rewrite the formula. It's CuCl2 and then dot X H2O. After the heating, we have 2.69 grams, and this is the copper 2 chloride salt without the H2Os. So if we take the difference of these two masses, what we're going to get will be the mass of the water. Right? And the mass of the water is going to be 0.72 grams in this case. So now we know how much water was a part of the overall mass of the hydrate, and we know how much mass of the anhydrous salt. So I used a word there, anhydrous. Simply means no water. no water. All right, so now what we want to do is we want to figure out our formula. So we're going to drop down the mass of the copper 2 chloride, and we're going to drop down the mass of the H2O. And we need to find the moles of both, all right? Like the other kinds of calculations that are done in chemistry, we can't ever compare masses directly. We need to be in units of moles. And the X here that we're solving for, this is in units of moles. It's in units of moles. So for every 1 mole of the entire compound, there's going to be X moles of H2O. And X is going to be a number that's usually greater than or equal to 1. It should be greater than or equal to 1. All right, so we need to get the moles of our anhydrous salt, and we need to get the moles of the water. All right, so the molar mass of the copper chloride is shown here, just for simplicity. And the mass of the water is 18.02 grams. All right, so we get the moles from this. We shift colors again. All right, so the moles of copper chloride, the anhydrous salt will be 0.02. And I'm just going to string my numbers out. I like to do that. And the moles of the water, okay, now we're ready to take our ratio, and we're going to take the ratio of moles of H2O divided by the moles of the CuCl2. Now the reason I'm going to do moles of H2O divided by moles of CuCl2 is because of this issue right here. Most of the time X is going to be greater than 1. So I want to take the ratio in order that a whole number pops out rather than getting a decimal. So we're going to divide the moles of the water by the moles of the copper chloride. All right, and what we get is 1.997 or 2. So the formula of our hydrate is going to be CuCl2 dot 2H2O. All right, and let me just clean this up a little bit because I don't want you to think that I just wrote the symbol for calcium. So it's, whoops, copper. All right, now, sort of as an aside, but equally important here, what I'm going to do is go ahead and translate our formula right here into its correct name. So it's going to be copper 2, because it's copper plus 2. All right, chloride, and then there are 2 H2Os, so it will be di, and then the word hydrate.